Elika is also known as Fantasai, is a longtime contributor to the Mozilla Project and an active member of the W3C CSS Working Group, where she accidentally stumbled into internationalization. Looking forward to hear about that because she co-edits these specifications that we're going to talk about today, including Bidi, vertical text, and internationalization, international typesetting features. So you're done hearing from me now, and we're going to invite our speaker up. Like she was saying, she'll tell you when to ask questions. I'm watching you. All right, thank you.
The microphone. Hi, I'm Fantasai, and I'm going to be talking about Bidi. As we said, I've been with the Mozilla Project for a long time, since 1999 actually, and I've been on the CSS Working Group since 2004. I was pulled in to edit all the internationalization features, basically. They were all in one spec, now they're in 3 because it takes actually a while to, a lot more text to explain things than the original author thought it would. So, okay. Here we go. So I guess we can start with what is bidirectional text. Bidirectional text is when text goes in 2 different directions within the same paragraph. So if you mix left to right and right to left text, you can see that on the first line we're going all the way from left to right. On the second line, however, there's a section where we have to jump over and go right to left. Bidirectional text also occurs even if you have a purely right to left language, because numbers, even the numbers in the Arabic script, are left to right. So as you can see, this paragraph generally goes from right to left, but there's this little number there that goes in from left to right. So basically, as soon as you expect to have any right to left text, you're going to have to deal with Bidi. So text is stored in its logical order, not the visual order. The logical order is the order that you read it in, not necessarily the order that it appears on the page. So, for example, if we take the words in this phrase here, we can see that the order that they're stored in doesn't quite match the order that they appear in on the line. The visual order, actually, and there's a good reason for this, the visual order, it depends on the line breaking. So if we break the line halfway inside that right to left bit, we find that 3 and 4 are now next to each other, even though 3 and 5 used to be next to each other. This is because 4 logically comes before 5, and so when you break between 4 and 5, 5 has to go on the second line and 4 stays on the first one. So I'm going to dive into the Unicode bidirectional algorithm and explain exactly how it works. Okay, maybe not exactly, but mostly how it works. There's a lot of details which you can read in the exciting Unicode standard annexes. The basic order of operations here is first we classify all the neutral characters. Next we assign embedding levels, which are numbers. And lastly, we reorder by number. It's kind of like paint by number, except we're reordering things. So resolving neutrals. All Unicode characters are either strong left to right characters, such Latin, Chinese, almost all the languages of the world are written left to right, or modern languages. Or they are strong right to left. There's a handful of scripts, Arabic and Hebrew being 2 of the most common, that are written right to left. Or they're neutral. So spaces and punctuation in Unicode are neutral characters. So the first step in Bidi is to figure out, well, what do the neutrals resolve to? One of the details we're going to skip is what numbers are, because they're kind of special. But we will pretend that they're left to right. So the simple rule is there's a sandwich rule. If you have a neutral that is surrounded by two strong characters of the same directionality, then it takes that directionality. It's a very sensible rule, very easy. But there's some places where this doesn't work. For example, what if you have two different directions, one on each side? Or at the beginning or at the end of the paragraph. If you kind of get that wrong, you might have your period on the wrong side of the sentence. So to solve this problem, each paragraph has a base direction. In HTML, the base direction is per block element. Block elements are things like p tag or div tag, so things that are generally rendered as blocks. And this is the base direction is given by the dir attribute on these elements. In plain text, where there is no markup, it's per paragraph, where a paragraph is any section of text that is broken, doesn't have any line breaks in it. Although there's one special line break character that doesn't break the Bidi paragraph, it just breaks the line breaking paragraph. But for the most part, it will be between line breaks. You decide it by the first strong character. So you start scanning from the beginning of the text, and the first strong character you get determines the directionality of the entire paragraph. Most of the time this works, sometimes it might not. So the base direction is what we use when we have initial, final, or conflicted neutrals. That's how you resolve them. So the next thing, once we've resolved all of the neutrals, so it means all of the characters in our text have been decided to be either left to right or right to left, we assign every character to its embedding level, and we start by setting it all to the base level and then increase by 1 as required by the directionality. Sorry, that should be assign all to the big character. Okay. Anyways, so here's an example. In the numbers, left to right levels are embedding levels are are even, and the right to left ones are odd. So here we have the text. There's some neutral characters in there, and there's some left to right and right to left characters. And once we resolve the neutrals, they've all gone away. Then we need to assign some numbers. And so we set them all to 0, and the right to left text has to increase because it has to be odd, and it increases to 1. So one of the conventions that are used in a lot of examples are that lowercase letters are representing left to right text, and uppercase represents right to left text. So this way, like, you don't have to deal with, I can't read Arabic. We can look at nice alphabets and everyone can understand. So this is basically the pattern that we just saw. If you have a right to left base direction, then you start at 1, and then you increase to 2, because the left to right text started at 1, and it was like, well, but I need to be even, so in order to make me even, we increase it by 1, and it becomes 2. Just like that. Then the next step is reordering the text. So for each level run, which is you reverse the order of characters and then reduce their level by 1. So the level run is a number of characters that all have the same embedding number. And it looks kind of like this. So here we have A, B, C, D, F, G, H, I, J. This is the logical order, and we've laid it out. And then now the D, E, F all have 1s, so that forms a level run because they're all next to each other with the same number. And then we flip the order of all the characters in that run and decrease their number to 0. And now the text is in the correct order. The right to left text is going right to left. In the case where we had the RTL-based direction, we had higher number, right? So we had ABC with right to left, DEF is left to right, and GHIJ is right to left, and the whole paragraph was declared to be a right to left, so it means the DEF is a 2. And now that we've got our numbers all sorted, we flip the level run, which is the DEF, it becomes FED, And now we've got a whole bunch of ones, and all of those get reordered, just the entire thing gets flipped. So now we have the right to left text goes right to left, the left to right text goes left to right, and the overall order of those segments goes from right to left because that's the base direction of the paragraph. So the next advanced topic is embeddings. And the question is, well, what's an embedding and why do we care? So if we have all this like magic, right, why doesn't it work? It works for the simple cases. For example, we have this short Arabic, Farsi word in a English sentence, and it goes right to left, no problem, just by following the steps that we had previously. The overall order of the sentence goes left to right, but we've got a little bit that goes right to left inside. Even if we have two words that are of an opposite direction, it still works just fine. But sometimes you have this kind of like nesting structure. For example, here's a sentence that's got a quote in the middle, and the quote is left to right, and that quote goes left to right. Okay, fine. But let's say that quote itself had some right to left text inside it. So the quote was going to be this sentence, which goes in the other direction. And then we wanted to put that inside the other one. It doesn't quite go in the right order because we started with our right to left text, and then we go left to right, and then we continue right to left, and we go left to right, and then we continue right to left. But the structure is that there's kind of this like paragraph inside a paragraph, and so it didn't get ordered correctly. What we want is this. We want that whole thing just to like drop it in right there and like go in the correct order. Like that. So there's basically this like left to right thing that happens to have a right to left thing inside it. And that whole thing is inside the overall right to left thing. Like that. So yeah, embeddings are markup that creates a paragraph within a paragraph. It does this by increasing the embedding level by at least 1 with regards to surrounding text, and it sets the base direction explicitly within that run. So in this example, we can put an embedding around the left to right quote and say this is the left to right paragraph inside our right to left paragraph. And what that does is that the surrounding base text is like all at level 1 because that's the base. The base paragraph is 1 for right to left, but now we have an embedding and it says, hi, I'm left to right embedding. We need to increase by 1. And so that becomes a 2. And then we have the implicit stuff that the right to left text says, hey, I can't be at 2. The right to left text in the middle says, I need to be an odd number. So it gets increased by 1. And then we get 3. So it kind of looks like this, basically. So here's an example of looking at an embedding here. There's the numbers. And then you can, and then we do our reordering by numbers. So we started out with 3, and then we flip that little section. And then now this longer thing is a 2. And then we flip that entire thing. And then now it's all 1s, and then we flipped the whole sentence. And that gets us the correct ordering, which is starting with A all the way on the right, and then going to our left to right thing with the text and the right to left inside. So that's how the Bidi algorithm works, if we ignore some of the edge cases. Does anyone have any questions? Yes?
How do you determine like the polling? How's the direction? It's a bi-directional.
Hmm?
Polling.
The
Quotes.
oh, the quotes? Oh, okay. Quotes are a somewhat advanced topic we won't cover here. There are basically quotes are neutral characters, but they also, I think certain quotes or brackets, these kinds of paired punctuation get mirrored and some of them don't. And I can't quite remember which ones do and don't. But you can look that up in the Unicode standard. Yeah. So The base, I think, if I recall correctly, the left parentheses is really opening parentheses or something like that. Yeah. Yes.
I want to ask about reordering the directionality. It's a situation that, for example, an English sentence explaining something in Arabic. What techniques exist? Products, for example, will take first character, basically, first one. Or is other products that do different things?
Okay, so the question was about auto-determining the base direction of a paragraph in plain text, and what happens if you have, for example, an English paragraph that starts with an Arabic word. How do you deal with that? So there's basically a bunch of different ways of automatically determining what the base paragraph direction is, and sometimes different editors will use different techniques. The one in the Unicode standard that it requires for displaying plain text is you take the first strong character. Now, if that's not the correct direction, there's an invisible set of invisible characters that are basically, they don't do anything except they're a strong character. You can't see them, you can't touch them, can't smell them. They just sit there at the front and tell you what direction that they are. And they're used for, you can use those to trick the algorithm, the first strong algorithm, into setting the base direction to something that's not the first visible character. They're also used for other things where you need to fix problems that the intrinsic handling of Bidi doesn't work quite correctly, and we will get to that.
I did have one question just to get into that. There are situations in self-text localization where you have a variable embedded within a string. And since the variable's value may not be known until runtime, you will have the situation where sometimes you will not know in advance what directionality it should have. Is there any mechanism given to basically apply the algorithm of determining?
We will get to that. I will answer your question in the next section. We're not done. Or maybe the third one. I can't remember. Okay, so there's markup in HTML4. And this allows us to provide some guidance to the Bi-Directional algorithm on where it doesn't get things quite right, or to explicitly set the base direction. The most important bit of markup in HTML is the global dir attribute. And global means it's valid on every element in HTML. And it takes two values, LTR for left to right and RTL for right to left. And what it does on a block, it sets the base direction of that block. And then on an inline, it creates an embedding with that stated directionality. Directionality in HTML inherits. Embeddingness doesn't inherit. If an inline sets an embedding, then it sets an embedding, but any inlines inside it don't. But the directionality does inherit. So if you want to set the directionality of an entire section or the entire document, you just set it on the element that contains all of that, and it will inherit through to all of its descendants. The default is not auto-determined, it is LTR. So if you have a right to left document, you must put a dir attribute on it in order for it to render correctly. CSS, there's some side effects of setting the directionality in CSS and basically in layout. Directionally affects the default text alignment. By default, left to right text is aligned to the left and right to left text is aligned to the right. It also affects the ordering of columns. So if you have a table, you're going to mark that up in logical order, and the layout engine will put the columns in the correct order based on the direction. It also controls the alignment of overflowing blocks. So if you have like a really big image, it'll overflow to the right, except when you're in an RTL context, in which case it'll overflow to the left. And obviously it affects the ordering of text. CSS2 also has a direction and Unicode Bidi properties. You should not ever use these. These properties are automatically set by the user agent, by the browser, and based on the markup. And you should use the markup because the markup will always work, even if you turn off style sheets or whatever. It's much more reliable, and it's not about styling. It's really about just getting this actually correct. So use the markup, the dir attribute. Don't use direction in Unicode Bidi, even if it seems convenient. So the basics of working with HTML is, the really basic thing is, hey, I have an RTL document. It's all RTL. Stick a dir attribute on the HTML element, and that'll just inherit through the entire document, and no worries about anything. If you have a little bit more mix of languages, you might have, for example, a block quote. You're talking about, some other language quoted poetry or something. You might need to swap directions, so you can use the dir attribute on, for example, the block quote or the div element or a paragraph. And that will change the base direction of all of those paragraphs. And then if you have an inline quote, then you can use the dir attribute on an inline element, and it will set an embedding, and that usually works. However, this doesn't always work. Sometimes you run into problems, and there's basically two classes of problems when you're dealing with Bidi. One is insufficient combination, which is there's a bunch of text that is not sufficiently tightly associated with each other. And the solution to that is to use an embedding and make them group more tightly. The other problem is insufficient separation. So if you have that problem, you use a right to left mark or a left to right mark. These are the characters, as I mentioned. They're invisible. They do nothing except sit there and be strong. And they will help you split up things that would otherwise glom together. So here's if you want to create separation, let's say we have our sandwich rule. If you have a left to right text and then the neutral text and then the left to right text, it all becomes left to right. Sometimes you run into a problem. For example, in my example, I have a list of languages, and I happen to have Hebrew and Arabic right next to each other, and because they're both right to left, well, I wanted Hebrew to be first in my list, but it's now second from the perspective of the person reading it because it's in a left to right sentence. And so this is all glommed together, and it's now this one long RTL string, and so they've kind of swapped places. And we solve that by adding a left to right mark right after the text there, and then it'll appear in the correct order. Sorry, I put the Arabic first. There's some problems with the way embeddings work. Like, fundamentally, they were misdesigned in a couple ways. If you put two embeddings right next to each other and they have the same embedding direction, they will kind of glom together and become one big, long thing, which is usually not what you intend when you're setting an embedding here, because you're like, oh, well, in between it should be, left to right here, because I just have these two pieces of things, and I want the pieces of these things to be like together within themselves, but I didn't want them to like join together and become one long thing. But there's just a bug in an algorithm, and that's something we have to deal with. Another issue is numbers are kind of weird. We didn't talk too much about them, but they can, in certain circumstances, jump to levels of embedding, so they can attach themselves to nearby embeddings or even flip into embedding or just do fun acrobatic tricks. So the short story there is that embeddings suck. Lucky for us, there's a guy at Google named Aaron Lannon who's trying to fix all these by introducing new features into the Unicode and HTML specs. But right now we're kind of still not quite there where it's widely implemented. So sticking with HTML4, we're going to look at how to solve some of these problems. A couple rules that will help when you're dealing with text. If you know you've got, let's say you have user input, If you know the string's directionality, you should embed it. Like if it's stuff, if you don't know, you can always embed it. Or if you want to do some kind of auto detection, you can only embed it when it's different. But if you have some user text you don't know, it's best to put it in an embedding. If you have 2 or more user strings that appear in a Bidi paragraph, separate them. And by separate them, I mean you need to put some kind of strong character of your surrounding user UI language, being like this, to separate them so that they don't kind of join together into one long Bidi thing. So for example, if you have a title and then a dash and then an author, and both of those could be any language or any script, in order to get them in the correct order all the time, you need to put some kind of separation there. You can have the dash, that's fine. Just stick a left to right mark, and then you'll always have your title first. And the other thing is beware of numbers in your user interface. You want to embed number punctuation sequences like serial numbers, MAC addresses, phone numbers, product numbers, whatever. And also separate those numbers from any user input, because we don't want them to have fun with embeddings that are near them. And the last thing is strip any trailing spaces in an element, because the spaces, when spaces collapse, one of those spaces gets kept, and you will often get the wrong space if you have trailing spaces in your elements. So auto detection, there's a bunch of heuristics as we went over. One is like percentage of right to left text is above some kind of threshold, and we can assume it's a right to left paragraph. But the one that is in Unicode and the one that is now in HTML5 is first strong, and there's a number of advantages to this one. It's simple, it's really simple, it's predictable, it's controllable. You can control it by adding neutral characters at the beginning, and it's compatible with Unicode plaintext. No heuristic is always right. It is just a heuristic, so sometimes you have to tweak it. That's the end of part 2. Are there any questions? Yes.
How does adding neutral characters at the beginning help?
Not neutral, sorry. Left to right and right to left marks. Yeah. Invisible characters. So HTML5 is introducing this fantastic new feature that'll make all our lives much easier when dealing with Bidi. It's called isolation. It fixes all of the suckiness of embeddings. There is absolutely no leaking between the embedding and the surrounding text, and the entire thing that is embedded is treated as a neutral within the context of its surrounding text. It's very tree structure friendly, which is great for HTML. You just wrap it and move along. And it pretty much eliminates most, if not all, of the need for left to right and right to left mark tricks. So for example, my previous example where I had to stick a left to right mark to make that comma kind of behave like a left to right comma. No problem anymore. I just wrap it in a BDI element, and each bit of right to left text gets wrapped in its own little bit of isolated right to left. And from the perspective of the outside paragraph, it's just a neutral thing that it just gets reordered wrong with the rest of the text. Another nifty feature is dir equals auto, which is a new value, and it provides browser-side first strong auto detection. So it auto detects text according to the first strong algorithm, and it's great for phrases. You can use it for single paragraphs. It triggers isolation when you use it, and it has special handling in pre and text area, which are typically contain some kind of plain text that's not marked up much. Inside pre and text area, it performs per paragraph checking based on line breaks, just like plain text. It does automatic alignment, so right to left text will be right aligned, even if you've got a bunch of different paragraphs inside, then no markup inside. And it's compatible with the plain text rule. So basically, if you take a plain text email that was written to display correctly in a Unicode conformant viewer and paste it into a pre or paste it into a text area, it will look exactly the same. There's some new features in CSS3 as well. There's direction-based selectors. So You can say for right to left elements, style them this way, and for left to right ones, style them the other way. This triggers based on the HTML dir attribute. It does not trigger based on any of the CSS properties. Another reason not to use the CSS properties. And these are also processed after dir equals auto is resolved. So if you have an if you have an automatically detected paragraph, it will match correctly based on its content. There's also new values in the text align property. Before you had left, right, and center and justify. Now we also have start and end, which start means to start, whether that's left to right or right to left. And the end obviously is the opposite of that. And then there's a new value called, oops, match parent. Yes, this is indeed embarrassing. All right. And the match parent value basically says, I want to be the same alignment as my parent, which is great for like lists or option elements. Because sometimes, like, let's say I have a list of pick your, your language that you want to read this page in, and Hebrew is written in Hebrew, and so I put li dir equals RTL, and then all of a sudden it's on the right side of the page, whereas everything else is on the left, and that doesn't look so great. So text align match parent says I want to use whatever my parent was, like absolutely, not inheriting the start value, but inheriting left or right after it's been computed to one or the other. And that can be handy for some situations. Okay, now we go to next. So references for more reading material. You can read Unicode Standard Annex number 9. It will tell you exactly how the Bidi algorithm works. There's also, Aaron wrote a nice document explaining problems with embeddings and current HTML markup and situations where we want something new and problems to solve, and that is got some great examples to read. There's a Bidi tutorial link, and then there's the www international mailing list, which is where the W3C discusses things like this. So that's it. I'm done with my slides. Does anybody have any further questions? Yes.
So consider that we use isolates in HTML5 with markup and everything. And then I copy paste the paragraph, like the paragraph that you showed, and just put it in a Unicode couple and text section.
Okay. So the question was, what happens if you have all a great markup on your HTML document and you copy and paste it into a plain text context? What happens? And what happens will depend on your browser. I suspect you will not get anything particularly sensible. But it is entirely possible for a browser to say, if I'm copying to plain text, I'm going to do some markup magic to preserve the HTML directionality controls as Unicode control codes. So I don't know if any browsers implement this. It's possible they do or will. If you think they should and they don't, you can file a bug. But yeah, Unicode has corresponding control codes now that match up to the isolation features in HTML5 so that they can both be expressed in the identical ways. So you can definitely have that. That's definitely possible. As for whether it's implemented, I don't know. Any other questions?
But the isolates,
Mm-hmm.
you're saying that whatever be applied once. Example that I was thinking of is a case where, let's say you have a some sort of token, some sort of variable, and it's either user input or something that will determine it. Let's say that what it contains is within the Arabic sentence or product name, name Abu, for example, has a usual character at the end of its. And there are also Arabic and Hebrew. Will the exclamation point end up on the correct side?
Okay, so the question was, let's say I have a variable inside my document, and that contains some arbitrary bit of user input text, which may or may not end in some neutral characters. Does the isolate handle that? So if you use dir equals auto and auto detect the direction, then yes, it will handle that because it will auto detect the direction, and basically an isolate is really like a paragraph inside a paragraph. Like I said, there's no leaking, and once the base direction of that is set, for example, Yahoo starts with a Y, that's left to right, strong. So it'll say, if you use dir equals auto, it'll say, this starts with a Y, it's left to right, strong. The base direction of this paragraph is left to right, and then the exclamation point will come at the end.
So we'll treat the embedded text as if it were the beginning of the document, essentially.
Yes. Within if you use dir equals auto within a paragraph, it will do its auto detection as if it was its own little paragraph. Yeah. Next question. Okay, so the question was, if I have a text area and the user is typing things, and it's dir equals auto, how do the CSS selectors respond to that? I believe currently that they will swap around depending on what the user types. But it's a good question, and maybe that's not a good idea for text area. So that might be an issue in the specs that we should think about, and we figure out what's the right answer there and edit the specs as necessary. So yeah, right. So there are other selectors that are changed by the user. For example, there's a whole bunch of pseudo classes that trigger on form validity. So as the user types into an input field, it might change from valid to invalid. So that's not JavaScript. That's because you can do declarative form validation. There's also things like the hover and active. So there's definitely selectors that will trigger based on user interaction with the page without any JavaScript at all. So this is not a new situation. As for whether that particular interaction with the text area makes sense or not, that's a good question.
The user can set the direction of the text area, right? Because it puts scroll bars, and usually there's a role for that, where they can in the browser say, I want this to be left to right or right to left, and scroll bars change around, and they can input. I think that would drive the direction of the text area.
I think if you put dir equals auto, then it should probably just do auto detection and not swap. And if you override that with the user control by saying, actually, I want this to be right to left, then it should treat the whole thing as right to left. Yes?
With notation, if I have anything to say about determining the direction based on
No.
particularly relevant for email, display email messages. Not dependent on UI.
Right. So the question was about, does the HTML algorithm have any other auto detection algorithms? And the answer is no. The HTML5 only does for strong detection. And this doesn't always get you, like I said, this doesn't always get you the correct results, but it should be interoperable with any Unicode conformant plain text viewers. Now, there's definitely a whole bunch that aren't Unicode compliant. If you're writing an email editor, it might be a good idea to make your text that your user types and sends to be Unicode compliant by inserting the right to left or left to right marks. That might be something to do because then it will display correctly wherever, hopefully. There,
First strong works well with one line input field. Multiple lines.
so, but the thing is that when you have plain text, you don't have any contextual information. You need one algorithm that you apply to every plain text document that your viewer views. And so it's not, if some programs use one algorithm and other programs use a different one, then you have a problem. And this is particularly a problem with email. And it's like, so if you have some email viewers that use first strong and other email viewers that do %RTL, they will not be able to interoperate. And that's kind of a general problem, whether they're implemented in HTML or C++.
But you can still have multiple approaches as long as you have a mechanism for declaring what's appropriate for that document.
Yeah, but you would need that declaration to be in Unicode because you're swapping around plain text. If you're swapping around markup, then just use the markup to set things appropriately.
What would be nice is at least have some recommendation how to implement. Not just a first strong. May not be a really strong recommendation, but some consideration.
I mean, yeah, we can write a document about how all these other auto detection cases might work better for these other cases, but that unless you are also carrying around somehow information about which algorithm to use, this isn't helpful for interoperability. If you're carrying around that kind of metadata, you might as well just carry around the actual direction of the text. But like I said, if you've got like one person that says, oh, I authored this email and it works fine in my email thing, and I send it over and you're looking at your web client and it's doing a different algorithm, they're not going to display correctly. So somehow you need to get these two programs to agree on how they're doing auto detection. Now, if first strong doesn't work great for my email, I'll see it while I'm editing that email and try to fix it somehow. And then whatever I see should be what you see once I send it. If we're using different auto detection algorithms, then that's not necessarily going to happen. So, like, yes, it's a problem, but it's a problem that can be solved either by using some kind of markup, language instead of plain text, or by everyone just going with first strong and like just standardizing on like this is the auto detection algorithm and we're all going to use that. And then if it's not the right heuristic, people can at least tweak it and make things that when they look at it looks good, and when they pass it off to you, it looks the same. If we have different algorithms, you don't get that. You don't get interop.
When I say you, I mean product that you use, the editor that you currently use.
No, there is no specification. There's no way to specify in HTML or in plain text what auto detection algorithm you would like to use. No. It's kind of an odd thing to do in plain text. So, like, I mean, you're sending a plain text email. How are you going to say what auto detection algorithm to use it? And why would you say to use an auto detection algorithm? If you're carrying metadata, just carry the direction. I mean, you can have a smart editor and it says, well, this paragraph, according to my auto detection, is actually Arabic, and should be displayed right to left. So when I send it as plain text, I should put a right to left mark at the beginning of that paragraph to make sure that any other reader will interpret it that correct way. If I'm because interpret it the way I showed it to my user. So like first strong might not be the user interface, but it should be the exchange format.
Well, X9 is due to be updated. So from W3C point of view, does anything change over there or everything?
I believe there are no changes required to the CSS3 specs other than updating our references. And we can take a look at the CSS3 spec. But it's basically, it's the writing mode spec, this is the spec that we're talking about here, talks about direction and Unicode Bidi. And it basically explains how isolation works, and definitely embeddings haven't changed their behavior because that needs to be stable. It's an old feature. So it references the Unicode specs. Yeah. Right now, it's just referring to an undated URL. So if you land here, you'll get the latest, which is currently 6.2. Yeah, that will become, when that becomes the official one, then we will be referring to that. I don't.
No changes for your spec.
I don't believe so, no. We're not referring to anything that was, we're not necessarily referring to anything in 6.3 that needs to be, yeah. And if that needs changing, I am pretty sure we'll get an issue filed and somebody will like, you need to update this. We do have bug tracking systems at W3C. Yes, there are bugs in specs. It happens. Feel free to report them. We will fix them, or at least we'll try. Any other questions, Tex?
Yeah, so what's the rationale for not supporting the directionality functions from CSS? Because I found when I'm working with Bidi text, being able to use the language of the text to set font and other attributes, and then also have it declare the direction was useful and collapses the size of the page, because then I don't have to declare direction everywhere. So it seemed like it was very efficient to be able to do that, especially if text was coming out of the database. I knew the language of the text. I could just say, here's the language of the text, and from the language selector, trigger all these other attributes, and now I have to go back into the document and declare direction and isolation. Well,
yeah.
at least direction in various places.
So the question was about why can't I use CSS to set the direction? It would be nice if I could just, if I knew the language, to just trigger off the language and set the Bidi's controls correctly from that. One of them is that on the separation of content and style, we want the directionality information to be with the content. So if you lose the style sheet, turn it off, the text should still display in the correct direction, in the correct order. So that's the main reason, and it's in terms of detecting the Bidi from the language. I think it's been discussed a couple of times on the list, but people are kind of against that because they're like, well, there's kind of an open-ended list of languages that might be written, maybe not totally open, but like it's not as short as necessarily the two languages that you happen to support in your application. And if you're going to do it on the browser side, have them do language to Bidi mapping, you want that to be complete.
I wasn't interested so much in detection, because I can declare it and then use that from the CSS. So,
yeah, it's mainly an issue of separation of content and style, but there's also like side effects like, for example, the selectors won't work if you do this via CSS because CSS you can't select based on CSS properties. You can only select based on things in the markup document. And there's various features like that won't work correctly if you're doing it at the CSS level rather than the markup level. Other questions? All right then. I guess we're done.